Okay, this is the notes page for the remainder theorem, and it's here spelled out. It says if the polynomial p of x is divided by x minus c, then the remainder is the value p of c. If the remainder is 0, then c is a 0 of the polynomial. So what's happening here is you've got this polynomial. This is a potential factor. Okay, if the remainder p of c is 0, then that is a 0. C is a 0, so that is a factor. Okay, so what we can do is use division and the remainder theorem to evaluate p of c. If c is a 0, then factor the polynomial completely. So this is an example from the lab manual. Here's your polynomial. P of x equals x cubed minus 3x squared plus 3x minus 1. C equals 1 is the potential 0. And it says use long division to find the remainder. Okay, so long division, you have to really understand this connection. If 1 is a 0, or a potential 0, then x minus 1 is a potential factor. Okay, so when it says use long division to find the remainder, if the remainder is 0, then c is a root and x minus c is a factor. So we are going to use long division. So x minus 1 is our divisor, not 1, not with long division. You have to have the x minus 1. And x cubed minus 3x squared plus 3x minus 1 is our dividend, and we're going to divide. And we've learned about long division, so x cubed divided by x is x squared. And then distribute that, and that's x cubed minus 1x squared. And then you draw your line and change the signs. That's like subtracting. So then x cubed plus a negative x cubed is 0. Negative 3x squared plus 1x squared is negative 2x squared, and then bring down everything so you don't have to look anywhere but right here. Start over. Negative 2x squared divided by x is negative 2x. Multiply that, so that's negative 2x squared plus 2x, because negative 2x times negative 1 is positive 2x. Draw your line and change the signs, so that's going to become positive and that's going to become a negative. So negative 2x squared plus 2x squared gone. 3x plus a negative 2x is 1x and minus 1. One more time, 1x divided by x is 1. Multiply and you get 1x minus 1. Draw your line, change the sign, and you get a remainder of 0. So what that tells me is that x minus 1 is a factor because the remainder is 0. And that means that 1 is a 0. Okay? Let's really look at what the remainder theorem says, because there's a quicker way to do that than long division. Okay, so let's start over at the beginning. Let p of x equal this, and c equals 1 is a potential 0. The remainder theorem basically says all you have to do is plug 1 in to the function. So that would be parentheses 1, and it's being cubed, and then minus 3 parentheses 1 squared, and then plus 3 parentheses 1 minus 1. So I'm plugging that 0, 1 in, and when I hit enter, that 0 is that remainder. So the remainder theorem says you can just plug potential zeros in, and if you get enter, if it equals 0, that means it's a root. It's a 0. So we confirm that with the remainder theorem. We found out that P of 1 did indeed equal 0. Okay. All right. Now it says factor completely. Okay. So what we're doing is kind of like we've always done. If the teacher asked you, is 3 a factor of 6? You would say sure, because 6 is 3 times 2. And you could, if she said use long division to show me, 3 goes into 6 twice, 2 times 3 is 6, and the remainder is 0. Okay. Is 3 a factor of 7? Well, you could use long division to find out. Nope, there's a remainder, right? Okay. So if 3 and 2 is a factor of 6 and the quotient is 2, that means that 6 factors into 3 times 2. 3 and 2 are the factors of 6. So it turns out that long division is a kind of a cool way to factor. Long division is a cool way to factor. So it says factor the polynomial completely. Well, we just showed that x minus 1 is a factor because the remainder is 0. Well, the other factor is the quotient. So if I were to multiply all of this out, I would get x cubed minus 3x squared plus 3x minus 1. And so we factored. If you can find 1 0, then you can turn that 0 into a factor. Then you can divide with that factor and get the other factor. So it's a nice way to factor. All right, this is number 5 from the lab manual. All right, here's your polynomial. Here's your potential 0. Use long division and find the remainder. If the remainder does not equal 0, then c is not a root and x minus c is not a factor. P of c does equal the remainder, however, so let's see what happens. Okay, so this is a potential 0. Okay, what's the factor? Well, the 0, 1 has the factor x minus 1. And I'm putting question mark here because it's just a potential. All right, and it says use long division. So if we're going to use long division, we can't divide by 1. We have to divide by x minus 1. Okay, so x cubed divided by x is x squared. That gives you x squared minus, gives you x cubed minus x squared. Draw your line, change the sign. See, they have to be the same, so I caught my error. And then 2x plus x squared plus x squared is 3x squared, and bring everything down. Do it again. 3x squared divided by x is 3x. That gives you 3x squared minus 3x. Draw your line, change the sign. That's gone, and you're left with negative 10, and that's degree 0, so you're done. So this is a remainder. So what that tells me is that x minus 1 is not a factor, and that 1 is not a 0. However, a quick way to check that, instead of using long division, would just be to plug in that potential 0, 1. So that would be 1 cubed plus 2 times 1 squared minus 3 times 1 minus 10. And that remainder, negative 10, is what you get when you plug that in. That's what the remainder theorem says. Okay, so that means that this is not a factor and that's not a factor. So it is not possible to factor this polynomial with the given information. Okay, now the direction said to use long division, but I think it's time now to tell you about something called synthetic division. Synthetic division is if you've noticed, you always do the same thing when you're dividing. So synthetic division is an algorithm for long division. You can't use it all the time. In this class, we're really only going to use it when your factor is in the form of x minus r or x minus c or whatever. Okay, so I'll make it x minus c. All right, is the divisor. I said factor, it potentially might not be a factor, so let's say call it the divisor. So if x minus c is the divisor, then synthetic division looks like this. So we'll look at this example since we can see it. All right, so another way to divide and to see if x minus 1 is a factor is to put, so you start with x minus 1, and if you set it equals 0, you get x is 1. So the 0, the 1 goes in the box. See, synthetic division takes out all the variables. All right, then what you're going to do is you're going to put the coefficients of this dividend right here. So that's going to be 1, that's the x cubed term, and then 2, that's the x squared term, and then negative 3, that's the x term, and then negative 10, that's the constant term. Okay, I'll put constant since we're already using c. Okay, and you have to make sure that this is in descending order. If it's not in descending order, you'll make a mistake. And if any of these terms are missing, you have to put a 0 in there. All right, so the way synthetic division works is first you just bring down that number. And then what you want to do to get over the line, you multiply. So 1 times 1 is 1. Then you're going to add to get straight down. So 2 plus 1 is 3. Then again, you're going to multiply. 1 times 3 is 3. Then you're going to add to get down underneath the line, so that's 0. And then you're going to multiply. 1 times 0 is 0. And we usually put a little bar right there. And then negative 10 plus 0 is negative 10, and that's your remainder spot. Okay, so now you can put the letters back in. And what's going on is this is a degree 3 is what you divided into. You divided a degree 3 by a degree 1, and that's all you can use synthetic division for. If this were x squared, you couldn't do it. So it's always going to go down 1. So if we started out with x cubed, this is going to be x squared, and then that goes down plus 3x. And that's what we got up there with a remainder of 10, negative 10. So that's called synthetic division. If you wanted to use synthetic division up here, again, the factor is x minus 1, so 1 goes in the box, and then the coefficients, 1, that's your x cubed term, negative 3, that's your x squared term, 3, that's your x term, and negative 1, that's your constant term. And again, you're going to bring that 1 straight down, and then multiply. 1 times 1 is 1, and then add, that's negative 2. And then multiply, so that's negative 2. And then add, so that's 1. And then multiply, so that's 1. This is 0. So there's your remainder, and this would be x squared minus 2x plus 1. And that's what you got up there. But remember, you have to put, if there's a missing term, you have to put a 0 there or it'll mess up. Okay, let's look at more examples. Number 1 says, consider the following. There's your polynomial. Use the remainder theorem to determine which is a 0 of p. X equals 2 or x equals 3. Then factor the polynomial as a product of linear factors with complex coefficients. So now here's when the definitions are supposed to, you really have to know what you're doing. We're going to factor as a product, factoring is to write as a product, of a linear factor, that's a degree 1 factor, and complex coefficients just means that they may be imaginary coefficients, because complex just opens up the world to real numbers or imaginary numbers. All right, but let's take this one step at a time. It says use the remainder theorem, which isn't a bad idea. It's a quick way to go. Remember, you can plug these numbers in. So all we have to do to check is figure out what p of 2 is and figure out what p of 3 is. So I'm going to plug 2 in first, parentheses 2 cubed minus parentheses 2 squared minus 14 parentheses 2 plus 24. And when I hit enter, that's going to give me the remainder. Ooh, and the remainder is 0. Therefore, x equals 2 is a root and x minus 2 is a factor. Okay, let's see if 3 works. It's possible that it could. So I'm going to go up here and grab that. So just hit the up arrow twice. And then everywhere I see a 2, I'm going to change it to 3. And I got a remainder of 0. So this is interesting. So x equals 3 is also a root. And x minus 3 is a factor. Alright, so we have 1, 2 roots, but look at the degree. We'd expect there to be a third root because of the degree 3. And it has to be real, because if it's imaginary, there's gonna be 2 imaginary, never just be 1. So let's use synthetic division to find out what the factor is. That's the quickest way to do it. Since these are linear factors, I'm going to use synthetic division. So I'm going to put a 2 in, and I'll put a 1 and a negative 1 and a negative 14. That's x cubed, that's x squared, that's x. There's no terms missing. And then 24 is my constant. And I'm going to bring the 1 down. And then 2 times 1 is 2. Negative 1 plus 2 is 1. Multiply. 2 times 1 is 2. Negative 14 plus 2 is negative 12. Multiply. 2 times negative 12 is negative 24. The remainder is 0. So that's x squared plus x minus 12. But I'm not going to write that down because I know that 3 is also a 0. So this is pretty cool. You can just do synthetic division again on this. This is x squared. So we'll bring the 1 down. 3 times 1 is 3. 1 plus 3 is 4. 3 times 4 is 12. And there it is, a remainder again of 0 again. So that shows you that 2 and 3 were factors. It started out x cubed. This is x squared. So this is going to be x plus 4. And there's your third factor. So we're ready to factor. P of x, instead of writing it multiplied out form, the factored form is x minus 2 times x minus 3 times x plus 4. So we were able to factor it. Alright, number 2, consider the following. There's your polynomial. It says use the remainder theorem to determine which is a 0 of p, negative 3 or 3. Okay, so let's see what happens here. We can use the calculator. All you have to do is evaluate these and check the answer, and that's the remainder. And if the remainder is 0, it's a factor. If the remainder is not 0, it's not a factor. Okay, so 2 parentheses negative 3 cubed. And notice how I love the parentheses substitution method. Keeps me from having to worry about negatives. Parentheses negative 3 squared, that's going to be positive. If you don't have the negative around the parentheses around the negative, it gives you the wrong answer. Okay. Alright. And we got a remainder of 0. So that means negative 3 is a root, or a solution, or 0. That means x plus 3 is a factor. Alright, let's check 3. The same thing we'll do. We'll go up and grab that and get rid of the negative so we can evaluate 3. And that equals 30. So that means that 3 is not a 0. So we only have one factor. Alright, well we can use that factor because up before in the other page I said that a really cool way to factor is long division or division, and we can use synthetic division. Okay, so if we're going to use synthetic division and x plus 3 is a factor, then remember negative 3 goes in the blank. The 0 goes in the blank. And then the numbers 2 and then 1 for x squared, and then negative 13 for your x term, and then 6 for your constant term. And 2 goes down, then multiply, so that's negative 6, and then you add, so that's negative 5, and then you multiply, so that's positive 15. So then you add, and that's 2, and then you multiply, that's negative 6, and the remainder should and is 0. So what we have here, it started out x cubed, This is 2x squared minus 5x plus 2. And this is where this comes into play. It says factor the polynomial as a product of linear factors. This is a factor, and that's a factor. The problem is that's not linear. So you have to break that down again. And you could try factoring. I'm not sure it factors, so I'm going to use the discriminant. B squared minus 4ac. B squared, that's 25, minus 4 times 2 times 2 gives you a perfect square 9. So that means that factors. Okay, if it didn't factor, you would use the quadratic formula. So what we're going to do is we're going to factor this. The factors are 2, 2 and 1, so I'm fairly certain that's 2x and x. The factors are 2, 2 and 1. The outer and the inner terms have to add to be 5. So if I put a 1 here and a 2 here, that's going to give me a 4x and a 1x, and they add to be 5. I want them to add to be a negative 5, so the last step is these both have to be negative. Okay, so what does p of x factor into? It's degree 3, so we got 3 factors. We have the x plus 3, we have the 2x minus 1, and we have the x minus 2, and we did what we were supposed to do. We factored it. Not only did we factor it, we factor it as a product of linear factors. X to the 1, 2x to the 1, x to the 1. Those are linear factors. Okay, the last thing, finding all real exact roots of polynomials. So the steps are here. It says if necessary, find the factor associated with the given root. If the root has multiplicity of 2, then write that linear factor twice and multiply it out. Step 2, use long division or synthetic division to reduce the polynomial to a degree 2 quadratic function. And then once it's a quadratic function, then you can set that equal to 0 and solve by factoring or the quadratic formula. So let's see what we got here. So the way that we do this is going to feel very similar to what we just did. It's just now we want roots. We want solutions. We don't want factors. We want the solutions. And I do count off if you get that mixed up. So you have to know the difference between when it says factor, write it that way, and this one, find all the roots. Alright, so here's a polynomial and we're told that 3 is a root. Well, you should expect 2 more because the degree is 3. So how are you going to get the other roots? Well, step 1 says find the factor associated with the given root. So if 3 is a root, then x minus 3 is a factor. Okay. If it said 3 is a root with multiplicity 2, then you would have to do x minus 3 times x minus 3 and multiply it out, and you would not be able to use synthetic division. Well, you could. Maybe I'll do one. And then it says use long division to reduce the polynomial to a degree 2. Well, I'm not going to use long division. I'm going to use synthetic division. Okay, so I'm going to put 3 in the blank. And then we have a 2 for the x cubed term and a negative 11 for the x squared term. And I keep doing this. I wish there'd be an example with a missing term. If there was a missing term, you'd have to put 0 down. So far we haven't had any missing terms. Okay, so put the 2 down, multiply that's 6, add that's negative 5, multiply that's negative 15, add that's negative 8, multiply that's negative 24, remainder 0. So that's now 2x squared minus 5x minus 8. And it says find all the real roots. Okay, so after we get the quadratic, right there, step 2, get the quadratic, then you're going to set that quadratic equal to 0, and you're either going to factor it or use the quadratic formula. Let's see if we can factor it. Let's use the discriminant again just to see what's under the radical. So that would be b squared 25 minus 4 times 2 times negative 8. And that's not a perfect square. Okay, so that means that that radical is going to stick around, which means that this does not factor. So we've got to use the quadratic formula. So the quadratic formula is negative b, which is positive 5, plus or minus the square root of b squared minus 4ac, which I've already found is 89, all over 2 times a, which is 2 times 2. So that's 5 plus or minus. The square root of 89 happens to be prime, so it doesn't reduce. So what are all my roots? I'll write them out so it's clear. The solutions, the roots are 3. Don't forget 3. 5 plus the square root of 89 over 4. And 5 minus the square root of 89 over 4. So the direction said to find all real exact. That means no decimals. 1, 2, 3, degree is 3, not a coincidence. Okay, so I said I would show you this one, so here we go. We have an example of a multiplicity. Find all real exact roots for this polynomial if we know that negative 4 is a root and it has multiplicity 2. So the way the directions say to do it is to turn that into a factor. That's x plus 4, but it's multiplicity 2, quantity squared. So you'd have to multiply that out. If I square double square, I get that. And then you could use long division to divide this into that. But it works to use synthetic division. Okay, so what you would do if you have multiplicity 2 is you just use negative 4 twice. So this is what's going to happen. So we have 1x to the 4th, 3x cubed, minus 36x squared, minus 176x, minus 192. So no terms missing again. All right, and we're going to divide with negative 4. The way we do it is we bring that 1 down, we multiply, so that's negative 4, and we add, so that's negative 1. We multiply, so that's 4, and then we add, so that's negative 32. We multiply, going to need a calculator here. So negative 32 times negative 4, 128. And then we add, so let's add a negative 176 to that value, and that's negative 48. And then we multiply, so let's multiply negative 48 times negative 4, and that's 192. And the remainder is 0. It better be, because we were told that negative 4 is a root. So then what do you do when it's a multiplicity 2? The cool thing is you just use negative 4 again. You get to count that 0 twice, so you divide again by x minus 4. So then that's 1, and then multiply, and that gives you negative 4. And then add, and that gives you negative 5. And then multiply, that gives you 20. And then add, that gives you negative 12. And then negative 4 times negative 12 is positive 48, and the remainder is 0. Okay, so look at what happens here. You started out with an x to the 4th. You divided, these are the results, that's an x cubed. You divided by a linear factor, so that's x squared. So we still have to keep going. Okay, so now we're finally at step 3, set this quadratic. We were able to get it down to a quadratic equal to 0, and then you have to either factor that or use the quadratic formula. Are there factors of 12 that subtract to be 5? 1 and 12? No. 2 and 6? No. 3 and 4? No. So this we'll have to use quadratic formula. 5 plus or minus the square root of negative 5 quantity squared is 25. Minus 4 times 1 times a negative 12. All of that over 2 times 1. So that's 5 plus or minus square root. Let's see what this is. 25 minus 4 times 1 times negative 12 is 73. 73 is also prime. So you don't have to break down anything else. Let's make sure we are clear what the roots are. So the roots are negative 4, 5 plus or minus square root of 73 over 2. Degree 4, but there's 3 roots. Well, it still makes sense because this was multiplicity 2, so you count that twice. So 1, 2, 3, 4 roots, degree 4. So that's how you handle if your root has multiplicity. You can just use synthetic division twice.